All right. Good morning, ladies and gentlemen, and especially students at Khalifa University. It's my pleasure today to be a part of Khalifa University community webinars. And today, basically, my talk is going basically to target students and give them some insights about the petroleum engineering discipline and the technology that is using in this industry. So my talk will be about the use of technology in shaping the future of oil and gas industry. So this presentation is presented by me, Emad. I am an assistant professor in the Petroleum Engineering Department at Khalifa University. So starting with the outline of this presentation, first I'll give you a brief introduction to petroleum engineering, and then we will talk about the technology trends used in the oil and gas. And here I'm choosing like a couple of those popular trends of technology, including digitalization, digital oil fields, drones and robots, automation of drilling process, artificial intelligence, and Internet of Things. And then I will move talking about ADNOC, Abu Dhabi National Oil Company, and its vision about this technology and what they call by oil and gas 4.0. And then after that, I'll talk about the Petroleum Engineering Department at Khalifa University and their vision about this technology and what they offer students. And then before I wrap up this presentation, I'll talk about some job opportunities, the in-country value program, and some success stories. And then I'll wrap up this presentation with concluding remarks. So a brief introduction in petroleum engineering. Basically, petroleum engineering is a branch of engineering where students really need to look for hydrocarbons to try to check where they're stored below the surface. And here we're talking about thousands of feet below the surface. And basically, they need basically to quantify how large is that oil in there and look into the different techniques in which they can produce that oil to the surface. And one might think like there is kind of a pool that is there under the surface, like a swimming pool, but this is not. I mean, it's more complicated than what you think. So if we zoom in one of those layers where oil is stored, you're going to see that we have here the rock particles, solid particles, and there are some voids between the grains. And oil and gas, they're stored in those voids, right? So this is gonna make it so challenging to produce the oil and gas from there, especially those voids are in micro scale. They're so small, maybe at the size of your hair. And I need to highlight that the place where this oil is stored usually underneath the surface is called reservoir. So this is kind of our bank where oil is stored and we need to get it to the surface. And in order for us to get it to the surface, really we have to drill a channel which we call a well, right? And that starts from the surface and it goes below and it hits the target. And these wells could have different designs and shapes, and this is where petroleum engineer come into play. Now, talking about petroleum engineering phases, so there are different phases that incorporated in petroleum engineering. We're starting again with the reservoir where the oil is stored, and again, this is our bank. We need to understand it very well and use the latest technology of modeling to capture that reservoir. And then we need to look into the well port. This well, which is going to transfer the oil from the reservoir to the surface. And after that, we're going to talk about the pipelines, which is a mean of transporting that oil from the surface up to your processing plant where it's going to be processed. And then after that, you're going to transport basically all the byproduct of that petroleum. It might end up like in a gasoline, which you're gonna end up using in your car or any other forms. And then basically you basically start selling it and start making money out of it. This is the main reason basically why we're interested in the oil and gas, because of their high market value. Now, talking about how oil and gas, they're influencing our life, you cannot imagine. They're influencing every single aspect in our life, either in a direct way or an indirect way. Here's, for example, I'm showing a schematic on a 1 barrel of oil, which is around 42 gallons. And what uses does it have? So you're going to see that the major part of it, it goes like a gasoline, about 19.6 gallons where you use in your car. And basically another important chunk, it goes to run heavy vehicles like these trucks, big trucks, and some of them is used for the jet fuel, like fuel, but for basically for the planes, and then for running ships, and for producing liquefied petroleum gas, and any other products like plastic products, and even some of the fabrics, and even some materials which are in your cell phones that you have now in your hands, those different chips. So basically, talking about the energy equation, I know students, they're not interested about equations, but this is a very simple equation. If we think that for each person, he or she needs to have a certain standard of living, right? So they need to have a certain mean of transportation, like a car. They need to have a truck, they need to have electricity in their home, then they demand a certain standard of living, right? And this basically makes a certain energy need. So the more number of persons we have, the higher the population, the higher the standard of living, and then the more energy demand we require. And then basically this demand needs to be satisfied in a way or another. So basically there's several forms of energy to satisfy this demand, where we know that the most important so far and conventionally is the fossil fuel. We're talking about oil and gas, and then we have other, recently people start talking about alternative energies and other methods. But really what we're looking for in the future may be kind of energy mix out of these two, of the fossil fuel and alternative energies. Here's basically, I'm sharing with you a study in 2019 where basically in this study, once was it conducted in 2017, basically, you're going to see that oil in green and gas, they represent about more than 50, about even 60% of the demand. And coal is basically representing about 25% of the demand. And maybe the renewables, they're basically representing about 10-20%. And then basically the predictions for the future in 2040, that you're going to see oil and gas, they're still playing a major role, which is at least 50% of the energy demand, and coal is still in there. This is very important, and I need to highlight this, because once we start heavily using oil and gas, people, they thought that we will not use coal anymore. But there are still now major countries in the world that are still heavily depending on coal. And I think from the same perspective, yes, renewables, they will help us to satisfy share of our energy demand, but they cannot replace the need for oil and gas, at least for not the coming 50 to 100 years from now. So this is a good news for those who's planning to join petroleum engineering, that the discipline is really safe and the industry is safe for at least 100 years to come for you and your kids even, and your grandkids, I'm sorry. So why you need to be a petroleum engineer, and why petroleum engineering? Because basically petroleum engineering is one of the world's largest and most spread industry. And basically here in this country we have ADNOC, which is Abu Dhabi National Oil Company, is one of the biggest oil companies in the Middle East, is the second largest. And basically it has a priority of recruitment to petroleum engineering students. And this is what I heard from basically the top management, that priority goes to petroleum engineers. And basically petroleum, as I said, it's the most important energy source, and we expect it to be like that to 2040 and even beyond that for the coming 50 to 100 years. And petroleum engineers, they basically the highest paid engineers all over the world. They cross different countries and they work in different fields. So the whole world will be open for you. Now talking about UAE specifically and sharing the UAE map in here, you're going to see that we have different fields or reservoirs in which we produce that oil. And here I'm showing them in two colors. A red color, which are the field that we are producing from them right now as we are speaking, and another ones in green, and those fields have not been touched yet. So we're talking with some of those specialists in ADNOC. They're saying that out of those bread fields that we're producing, you cannot believe that we have just produced 15% during those past maybe 50 to 60 years of a production. So we still have around 85% of those reservoirs waiting for us, and still the green fields, they need also to be produced. And this is basically the treasure of oil and gas wealth that we're talking about in this country of UAE. Now, what about those greens? Basically, those greens, they're basically fields, they have more challenges, right? They're not easy to produce, and that's why we started with the ones in red. Now, what are some of those challenges? Well, the formation there is where oil is stored. It could be basically unconsolidated. The temperature could be very high. The salinity could be very high. There could be some channels there that it's difficult to have a control on the oil and gas in the subsurface. The oil properties could be heavy, or the reservoir itself, it could be offshore, it could be in the water, and it could be very deep, like we're talking about the 10,000 feet. And this is basically a representation of the whole reservoirs in the whole world. You cannot imagine that the conventional reservoirs, or what we call by the easy reservoirs that I showed before in red, those represent 30% of the global oil reservoirs. However, if we're talking about the remaining 70%, then these are the unconventional reservoirs. These are the hard reservoirs. These reservoirs, they need more money to produce, but not only that, they need technology in order to unlock them and in order to start producing from them. So this is basically the main channel, and this is basically now gonna pave the way to start talking about technologies and their role in the oil and gas. So basically talking about technologies, first let's see the challenges that really faced in petroleum engineering for adapting this technology and applying this technology. First, basically we're seeing that the whole world consumption is really increasing, and we have basically volatile oil prices going up and down. And we started basically looking into different forms of wells, those channels that we used to produce oil to the surface, and they're carrying a lot of risk, a lot of uncertainty. We produce a massive amount of data on a daily basis. And this data, unfortunately, is sitting in there, and we're not making any use of them. And basically, people basically they start need to talk to each other. They started need to integrate their efforts and look about using the technology option. And also I need to highlight that our assets, which are the structures in which we use in producing the oil and gas, whether they are subsurface or they are at the surface, basically they're aging, they're getting old, they're needing a frequent maintenance. And we are in a business, if you just stop it for a second for making a maintenance, then you will be losing millions of dollars, all right? So this is how critical is the time factor for us. I mean, to put all that into perspective, then technology is basically the way forward to overcome all those challenges and helping us to get over them. Now, I need to share one of the most important trends in technology that everyone is talking about today, which is digitalization. So basically, digitalization is the use of digital technologies and digitized data, which is going to improve the way of communication between the customer and the company. And this is basically you're going to have a faster transport of data and depend less on the human interaction. So basically less of hard copy documents and more of some soft copies and some fast ways of transporting the data. And the digitalization in the oil and gas is basically continuing to grow, as most of the oil and gas companies around the world, they're seeing a great benefit and use of it. I need also to say that several studies reported that if we can adapt digitalizations in our business, then basically we will reduce CO2 emissions. So this will make the oil and gas even more user-friendly and environmentally friendly. And then we will basically do some cuts on the water consumption and even some of the oil spills in the oceans. Now, talking about the benefits of data digitalization, first, as I said, the data digitalization is you go from analog and recording data signals and physical documents and photographs into some binary digital formats of bytes and bits, right? And then basically, if you're talking about the benefit, this will basically enhance analysis of data with really a very high quality, and it will expedite the decision-making process, which is very important. Again, we are in a business where time is very important. Time is basically money. And that will increase basically the confidence in the interpretation, and it will ensure compatible analysis and comparison with other software applications. But in order to do that, there are three main structures and pillars that they need to be addressed. First, we need to talk about the people. People are the most important thing in any organization, and in our industry, we'll value their contribution very well. They basically need to get together. They basically need to engage together, start thinking about how to digitalize the oil and gas fields and come up with those digital oil fields. The process itself need to be think about it. What a process we used to do in the past 50 to 60 years, and we're used to it, and now how we can disturb it in a more in a faster way, quicker way, and efficient way, and an easier way. And then the technology itself, which technology that we will use in order to help us doing that. There are several technologies in there, and they're basically depending on your data that you have in your company and the quality of that data. And then whether you're going to share this basically data on a certain screens, and you look into basically your different visualization techniques. So this is a survey that was done in 2017, and basically it shows that the top technology, it's always referring to the digital oil fields. And as I said, in the past, we used to document and collect data manually and infrequently, but starting from 2000, we started really utilizing data and having a fast automated mode of collecting data by installing sensors everywhere in the field. But I don't think we're still there of making use of the data that we collect. So digital oil fields basically provides performance tracking and equipment surveillance. So basically you can check your equipment status, and you can make sure when it's gonna fail, and you don't want to wait really for it till it fails. You need to take some certain precautions and you know, save the business at the right time. And basically in 2016, it was reported that around $30 billion are expected to be spent for converting different oil and gas companies into and fields into kind of digital oil fields. And this will make us very good because it will save what we call non-productive time and the invisible loss time, which is any losses in time during the process of producing oil and gas, which is again means saving a lot of money. Here is another technology I need to talk about, which is the use of drones. So people, they started talking about them, and especially because you can use them to access remote places where it's very difficult to be accessed by humans, and you can basically control them autonomously, and basically then you have a less human interruption, and you use them for monitoring gas emissions, you use them for security purposes, oil and gas spills and damages, and even inspection of your offshore platform. And basically, it has been reported really that the use of them is estimated to eliminate production interruption, and that's going to save about $4 million each process. And it's been also reported that their role in aerial surveying, right? So basically, here is an example of we have about 85 acres of a certain field or area that needs to be surveyed. With the conventional techniques, usually it takes about 81 hours. But now with the use of these drones, you can get the job done in only 6 hours. So this is basically the time saving that we're talking about. Talking about even the use of robots in the oil and gas. We might start seeing this soon, and here I'm going to share with you a video which is going to show basically a robotic dog, which is really doing a very good job in inspection and surveillance purposes. All right, so it's really amazing to see how this robotic dog really does the thing on your behalf and goes to inaccessible places and read the whole gauges and transfer the whole data at your fingertips. So it's very important and very inspiring technology aspect. Another thing I need to touch on is the automation of the drilling operation. Drilling operation is one of the most essential operation in the oil and gas, which it helps us basically to drill that well, this channel of transporting oil from the surface 10,000 feet, the subsurface 10,000 feet all the way to the surface. So basically today people they started talking about automating this process, and they're referring to what is called by a closed loop drilling. And this is basically where they keep continuously monitoring and automating all the drilling parameters. And basically they use different set of algorithms to send commands for the different tools basically there at the rig to control the drilling operation with less human intervention, if not at all with no human intervention. And basically that will make the process way much safer and efficient. And here I need to refer to a certain case which was done in the US in the Eagle Ford Shale, and that resulted basically in 43% in reduction from the time from spud to the total drilling time, and also it saved about $250,000 of the spendings per well. So again, we are in an industry in which we're trying to cut the human intervention in there, and that's gonna save us a lot of time. Here is I'm showing again an example between this conventional drilling process and the automated drilling process. You can see how many persons is involved here on the rig site where the drilling operation is taking place, and it makes it risky for them. And here how a single person can be sitting in the room and controlling the whole process of drilling from A to Z by the automated mode. And here is also another graph to support the use of this technology of the closed loop drilling system, the automated one, where you're going to see that 6 wells being drilled in South Texas, and basically it took on an average for each well about 6 to 7 days, so about a week to drill. And we're talking about 20,000 feet depth of a well, which might take several weeks to months doing it in a conventional way. Here I need also to talk about another aspect of technology, which is called automation of drilling operations. And here I'm referring also to the real-time operation centers, RTOC. So these basically are centers where experts in the oil and gas and specialized in drilling especially, they will be gathering around the round table and they will be checking the performance of the drilling operation on a real-time basis. All the data will be shown on the screen and they can take a quick decisions right on the spot to avoid any catastrophic event or any further delay in the work. And I need to highlight actually that we have one of these centers in ADNOC as we speak right now, and I'm going to highlight it later. We cannot talk basically about the technology without talking about artificial intelligence, which we keep hearing about it a lot today. So artificial intelligence is basically making the machines smarter and intelligent by simulating a human behavior and intelligence. And this we can see it nowadays in different aspects of lives. We can see it in the medical field. We can see it in making simulators that they're trained to do the job. We can see it in speech recognition, as what you have it in your Siri and your iPhones. And you can have it in some of the cars nowadays where would you have the drive assist basically option for your parking. And even in Google, where you go there in the Google research bar and type anything, and then Google gives you like different option. Do you mean this, or do you mean this, or do you mean that? So, and in the oil and gas basically is one of those business in which basically we're trying to do our best to make use of this technology and make our machines smarter. So another technology which is really important is the Internet of Things. An Internet of Things, people they talk about it today, which is nothing other than network of physical objects. They're basically exchanging and collecting the data among themselves. So basically you have a less human or no human interaction, and not even a machine-human interaction. So no human-human, no machine-human, everything is done between the machines themselves. And here I'm giving you an example for the iPhone that you're using today, and most of you have even your digital watch, right? And the digital watch and the iPhone, they keep basically sending information back and forth between them without your intervention. And the same thing even for the digital cameras. So basically, most of you, again, nowadays, they have digital cameras at your place, and basically you use your cell phone to transfer data and keep checking your home 24 hours while you're away. So this is the technology of Internet of Things. And basically, we're believing that oil and gas companies, by the use of this technology of Internet of Things, they can reduce or cut CapEx by 20%, and they're expected to achieve a cash flow about $300 billion in about 2025. So here is a small schematic on Internet of Things and the essential parts that you need. First of all, you need some tools for data gathering and data acquisition. And here, those could be your sensors that you install or your camera. And then you go basically to the phase of, we call it data analyzing and data processing. And this is where you use your data analytics, artificial intelligence, and other techniques. And after you analyze your data, then you need to have a medium where you're going to and basically transfer your data. And this is basically you will be your wireless connection, right? And we're talking about, we used to talk about actually about the 3G and 4G. Nowadays, people, they're talking about 5G. And 5G, you cannot imagine if you can utilize this in such a technology, how fast you can transfer this data between your different machines and get your job done efficiently and quickly. And at the end of the day, you can use those data to display them basically on digital screens, which is going to help you more in your decision making and analyzing your data, which again, ADNOC, as one of the leading companies in the Middle East and around the world, adapted this technology, and I'm going to show you an example of that in seconds. So if any company needs to apply technology or those major technologies that I discussed, and there's some others, then what are the challenges that they're faced for that company particularly. Basically, it's a time-consuming process. It's gonna take a while for you to adapt to this technology, find the best technology that suits you, and sometimes it might be expensive. But again, you need to look for the rewarding aspect at the end of the day once you apply this technology. So remote locations, sometimes it's having a difficulty in having data connection and access to the data on those locations. Some of the locations, they have less sensors, and we need to make sure that we have so many sensors there to collect the data. Digitally behind, most of the companies, more or less, they're still living in the 70s and 60s where they used to do things, and they're very hard really to, and they're resisting basically change. So this is some of the things we need to take into aspect, which is related basically to the cultural awareness. So all employees in a certain company, they all need to adapt to change and think how to move forward in this technology and help advancing it. But we cannot also highlight the positive aspects without also highlighting some of the major aspects, which is this technology will be basically prone to cyber attacks. And this is simple because everything will be shared through the network, and it might be accessed. And that's now why our role, we need to do our best to protect our data while it's shared and it's transferred. Talking about the oil and gas ADNOC 4.0, or the fourth industrial revolution, as what ADNOC believe, and this is basically the use of artificial intelligence, machine learning, and data analytics. So a quick glance through Abu Dhabi National Oil Company. It was established in 1971, and it has about 14 integrated operating companies under its umbrella. And basically, it's one of the largest world producing company. We're talking today about 3.5 million barrels of oil and about roughly 9.8 billion cubic feet of gas a day. And guess what? ADNOC vision into 2030 is even to increase oil production to 5 million barrels and even achieve the independency in gas by unlocking or looking for those gas reservoirs that they're challenging and use the technology to produce them. And who's gonna do that other than petroleum engineers and other than you students? So this is the vision that we're talking about. ADNOC is considered as a catalyst for Abu Dhabi's growth and diversification, with more than 45 years of experience in international even partnership with different companies around the world. Here we cannot talk about ADNOC without talking about His Excellency Dr. Sultan Al-Jaber, who's the CEO of ADNOC and the Minister of State. And I'm here quoting from him what he said basically in the 2019 Future Investment Initiative event. Let's hear what Dr. Al-Jaber said.
We have to admit that the energy landscape is actually being disrupted. It is being disrupted by new technology. It's being disrupted by new operating models, new business models, new forms of energy, new geopolitical order. Putting all of this together gives you only one option to choose from, and that is the fact that we have to embrace change. We cannot resist change.
Indeed, Dr. Al-Jaber, we really need to embrace change, embrace technology in order to make a better use of our oil and gas industry. And here I need just to talk about ADNOC vision and how they embrace the technology by having 3 digital centers. So the first one is called Panorama Center, and this center basically you have around like big screens which extending around the room, and they're basically collecting about 200,000 data points. And I'm going to have a video on that, which is basically focused mainly on the downstream operation where you do transport the oil from the surface to the end user. And we have also another center which is called Thamama Center, and this center basically is focused on the upstream operations, which is down 10,000 feet from the surface, the reservoirs themselves. So we try to understand this reservoir, we're trying to simulate them, we're trying to mimic them and make a visualized models out of them using different cells and so on and so forth. So this is a second important center. And the third center is the drilling real-time and monitoring center that I talked about before, where they basically can supervise in a real time the drilling operations to cut their cost and make the drilling more efficient and safer. And I'll share now two videos about the two centers basically. So this is basically a small video that I will share about ADNOC Panorama Center. And here's I'm quoting a speech of Mr. Abdel Nasser Al-Maghribi, the SVP Digital of ADNOC. Let's hear together.
ADNOC's Panorama Digital Command Center is a fully integrated, real-time data visualization center that empowers ADNOC's sharpest minds to gain insights, unlock efficiencies, and identify new pathways to optimizing performance.
Panorama is an example of what Abu Dhabi can do. It's a 50-meter screen that allows visualization with more than 120 dashboards that are very granular. We have brought in more than 200,000 data points into this location.
Aviva's System Platform and Operations Management Interface, OMI, are the foundations of the display, enabling integration across various ERP, business, and IT applications, and providing actionable insights.
I want also to highlight that recently it has been reported in May 2020 that the Panorama Center generated over $1 billion since its inception in 3 years ago. And basically it enabled ADNOC to stay agile even during the current pandemic condition of COVID-19. Talking a bit about Panorama Center and how it's used for enhancing production and recovering the best of the oil stored in the reservoir, I'm going to share with you also this small video. So in short, joining the petroleum engineering discipline and joining ADNOC here in Abu Dhabi will open so many floors for you and opportunities, and you will have access to these several digitalized centers with the latest edge of technologies. Now, I need also to highlight a remarkable event in UAE that was achieved by ADNOC Offshore and was announced in October 5th, 2019, which is drilling the longest well in the Middle East. And this well even considered around from the top longest 10 wells around the whole world. And this well depth is about 40,000 feet or around 12 kilometers. And in order to put those into perspective, how long was that well, you can imagine the distance from Abu Dhabi Museum, the Louvre Museum, all the way to the Emirate Palace. Now, talking about the petroleum engineering discipline in Khalifa University particularly, and basically how it's adapting the technology as well, and how it will make sure that you have all the fundamentals that you need to get adapted with the recent technology trends. So why petroleum engineering at Khalifa University? Well, that's because it's a local, popular, and recognized university by the UAE Ministry of Education. And basically it's an internationally recognized university, and that's basically even by the ABIT, the Accreditation Board of Energy and Technology, of Engineering and Technology. And basically you have several international recognized faculty members there. I'm going to glance you through their profiles in seconds. And also we have a state-of-art laboratories, which is really competing with the top universities around the world. And we're having opportunities for students to go to several conferences regionally and internationally, and even compete against other students. And this will even open the floor for you to be a student under ADNOC scholarship, and hopefully will open even the door for you to select ADNOC and join ADNOC by the end of the day, or any other operation company or affiliated company, as I'm going to highlight later. This is basically the undergraduate program for petroleum engineering. I don't want to go along through it. Basically, it's a 4 years plan, freshman, sophomore, junior, and senior, where we give in the main fundamental courses in every aspect in petroleum engineering to make students they have a strong background of what they need. Here is basically the profile of the different faculty members in the Petroleum Engineering Department at Khalifa University. I need to highlight that our chair is Dr. Muhammad Sasi, and we have around 8 faculty members, and then we have around 4 lab engineers and 1 secretary. And I need here to highlight even the local and the national caliber out of these faculty members, which is going to give you incentive for the local students in here, that this will be a role model for you and a place for you to be in the future. These are the different research areas that the faculty members they're active at: enhanced oil recovery or improved oil recovery, reservoir characterization, understanding that a place where oil is stored and making visualization out of it, unconventional reservoirs, which I talked about it before. These are the difficult reservoirs to get oil from, stimulation, workover and testing, flow assurance, drilling and completion, and artificial intelligence applications in the oil and gas, which is very important to stay adapted with the current technology in the oil and gas. Here is basically a quick glance through the laboratory facilities that we have. So basically, in being a petroleum engineer, you need to understand the 2 components, the rock and the fluid, because the fluid is stored in those small spaces between the rock, if you remember. So this is a glance from our laboratory rock properties to understand the rock. And here we have several laboratories even for understanding the fluid component of this business. And also I need to highlight the drilling simulator, which is state-of-art simulator. And maybe Khalifa University is the only university which has such a facility in there. And this facility is similar what you can see in a real field. But the only difference in the field that will be full of dust and mud, and here it's very clean and it's at your fingertips. So this is what we're trying to do. We're trying basically to shrink that gap between the education at the school and the real field practices. So if you join the department and study petroleum engineering in here, you will not feel any different if you than later once you go and join the companies. This is even a rock mechanics laboratory to understand more the mechanics properties of the rock. And I cannot move on without talking about the Society of Petroleum Engineers. So every engineers around the world, they have their own society. And for us as petroleum engineer, we have the Society of Petroleum Engineers, and we have our own chapter at the school, at KU. And that is even having a close communication with the SPE chapter of Abu Dhabi. And basically in this chapter, we have different technical and social activities. Some of the technical activities will be sponsoring students to go for different conferences, educational weeks, field trips even, and company visits. And usually we have technical presentations and talks on a bi-weekly basis where students, they can go there, communicate with SVPs and CEOs of the companies and other industry experts, and learn a lot from the current status of the oil and gas. And also our students will be able to have the opportunity to participate in both regional and international conferences. And I have also a couple of slides on that to highlight our achievements. And away from academics, also on the social aspects, we're arranging different sports days, several dinners, dog cruise trips, and visits to other chapters locally and even internationally. Here is basically a quick snap on some of our activities. Here we're talking about the Petrobol SPE competition, which is like a group of students competition, where we managed to achieve the 3rd place in Manama competition in 2017 and the 1st place in Manama, Bahrain in 2019. Those are all our male and female students. And then basically here I need to highlight the student paper competition, which is kind of an individual competition for each student, where one of our students achieved the second place in the Manama, Bahrain in 2017, and the other achieved the first place in Dhahran in US, in KSA, Saudi Arabia in 2018. Here also a glance of the several field trips that we arrange. Here I'm showing the Northeast PAB field trip by our students, and here is a trip for Das Island, and here also a visit to Al Riyadh industrial site by our students. Also, we're trying to make our best to make our courses, they have field trip component in there and site visits, and this will help students connect better the theoretical aspect taught in the class and how the reality looks like. And here I'm sharing with you a couple of pictures that they were taking during teaching one of the classes, and the student had a visit to Schlumberger Middle East Learning Center in Abu Dhabi, UAE. And here is another visits for the students, one in the PVT lab of Schlumberger and the other one in Core Lab in Abu Dhabi, UAE. And also our students, they have the privilege to get in communication with our leaders. And here I'm showing with you an event that happened in 2012, the World Future Energy Summit in Abu Dhabi, UAE, where here one of our students, she had the privilege to speak to His Highness General Sheikh Mohammed bin Zayed Al Nahyan, the Crown Prince of Abu Dhabi, and share with him her latest research breakthroughs. And here is one of our other students who's basically explained to His Excellency Sheikh Nahyan bin Mubarak Al Nahyan, the Minister of Tolerance, about his latest research breakthroughs. So this is the kind of chances that you will have once you join petroleum engineering in our department. Now, talking about other job opportunities, the in-country value program and student success stories. First, joining a petroleum engineering discipline, then this will open several branches for you under the whole umbrella of petroleum engineering to work at. You could be a reservoir engineer, which you're in charge about this place where the oil is stored, a drilling engineer to drill that well, a production engineer where you take care of how oil is at the surface, completion engineer to take care of that well design, and the well engineer as well, well service engineer, and operation engineer. And I have a short video that I can share it with you later if you have interest in knowing in details about the job of each one of these personnel. Talking about ADNOC and the in-country value program. So the in-country value program was basically embraced by ADNOC in 2017, and it has different objectives, and the main objectives is Emiratization. So this program will basically help in recruiting Emirati locals, not just in ADNOC, but in any other company which has affiliation with ADNOC. And this is basically including those companies where ADNOC has joint ventures with, like international oil companies, including PP, Total, ExxonMobil, ENI, OMV, and others, or even service companies, including Schlumberger, Halliburton, Baker Hughes, GE, and others. So you can see that our students, they now basically hired in those different companies. And I cannot talk about the petroleum engineering and its future without talking about the women's role in petroleum engineering. And I read here to highlight two successful stories. The CEO of Aliyasat today, who's Ms. Taiba Al-Hashimi, and the CEO of ADNOC LNG today, who's Ms. Fatima Al-Nuaimi, which is really making a good leading model for our female students to join the oil and gas industry with no fear. And I also need to highlight that one of our onshore field on land, which is Rumaita, today it's basically 100% operational by all women in engineering. So this is basically the future where the woman will have in our oil and gas business. Talking about several success stories, these are students who were that time at Khalifa University and the Petroleum Institute, which is the legacy part of Khalifa University, where they're standing today in their career. Ms. Salma Al-Hajri, who's today a director of Mubadala Petroleum. Mr. Khalid Al-Kindi, who's basically an SVP drilling in Advocate Drilling. Mr. Abdullah Al-Jarwan, who's currently a VP operations for ADNOC Offshore. And Ms. Sara Bakhti, who's a VP in TD International, and myself basically, because I studied at the school during my bachelor and master, and then basically I joined ADNOC scholarship program, and I went to the US, I got my PhD there in petroleum engineering, and I came back home today to the same school to teach you guys, and you get the best of the education. So I hope all of us will be a good role model for all of you to follow. Concluding remarks, I don't have much to say other than I need to highlight the say of His Highness Sheikh Mohammed bin Zayed Al Nahyan, and that's what happened basically during the 2015 Future Energy Summit in Dubai, where he said we shall celebrate when we send out our last oil shipment, which means basically we need to keep producing from those reservoirs till the latest drop, and that's basically because we still have around 2040 and beyond, 50 to 100 years, and even, you know, we need to use the technology trends to unlock these reservoirs that they're not being produced till now. So the challenges are there, and the future is counting on all of you. I need to acknowledge the Petroleum Engineering Communication and Student Activity Committee in Petroleum Engineering Department at Khalifa University, and I also need to acknowledge ADNOC Technical and Communication Departments for their help and assistance in preparing the material of this presentation. And I need to thank you all for really listening to this presentation, and the floor now is open for any questions. Thank you so much. So basically, couple of questions we received. One of them basically, do you have any tips for the students who are taking this major? Well, I'm not sure if this question means that recently joining students who wants to join or who already joined. But basically, this discipline is similar to any other discipline. Basically, nowadays we have access to the internet in all our houses, and all the information you need is on the internet. And our expectations now is even high, because at the school interview even, we ask the students what they know about the major that they want to select. So my advice for you, if you need to join petroleum engineering, just to try to read about this discipline more, try to understand it, try to build your passion with it, and basically check with others who's involved, because not all also what you read on the internet is correct. You need sometimes to hear from those guys who's really in charge in this business. I hope this addresses your question. The second question, does the UAE still uses coal, or I mean it means coal, or they only replace it by oil and gas? The UAE today, basically they're using both oil and gas in most of their businesses. I'm not sure if there is any coal use nowadays. Another question is, what are the side effects of the data digitalization? As I said, if you make your data digitalization, basically you're going to automate all your system, and you're going to transfer data between the different parts of your section. You're going to use your internet. Your main dependence will be on the network capacity, and that will be maybe unexposed or prone to cyber attacks, as what I highlighted in there. And then you need really to make sure you have a good security of data, because we are in a business where we spend on data millions of dollars, and that's why it's very essential for us to protect our data. Another question, which is, do you think that machines and the Internet of Things will replace the humans working in the field? No, we will basically have just a restructuring of thoughts in a certain company, and we will remodel basically the jobs that we used to do. Human input and a human role, it has to be there. We cannot depend 100% on the machines without keeping calibrating them and keeping tuning them from a while to another. But we're only going to give these simple conventional tasks for the machine to do it. And for us as a human calibers, we need really to move to better and more sophisticated jobs that we can, you know, handle and make the process way efficient and safer. Another question, which is it a hard major? Well, petroleum engineering major is basically like any other major. I don't think there is something hard. I believe if each student just put the time and the effort and they basically manage their time, they can success in any other major that they have. All right. So basically, is the keyword is time management, where I'm maybe one of you. So at the time of my school, I was laughing hard once I hear time management. But once I became more mature and joined now the professional career, I really started realizing what does time management means and what is the importance of setting priorities in doing the different tasks. I believe the last question on my list, is there anything related to graduate school studies? Absolutely. This is what I highlighted there. So now in our graduate school studies, we have actually both a master program and we have a PhD program, and several research faculty members, they're active in this aspect of technology and the use of and the application of artificial intelligence and machine learning in the oil and gas. So if you go and join our school, then hopefully you will have the opportunity to work closely with one of those faculty members if this is around your passion. All right, with this I want to thank you, and I hope basically you enjoyed that speech, and I was not too long, and I hope to see you all in the Petroleum Engineering Department and joining Khalifa University very soon, hopefully. And before me leave, I'm going to have a short video there on the role of different persons in petroleum engineering, so you can have more idea for those who are interested. Thank you so much. Stay safe and stay home. God bless you and bless UAE. Thank you.
Hi, we're engineers that work in the oil and gas industry.
Engineering specifically.
A petroleum engineering degree covers many oil and gas engineering topics, including reservoir characteristics and management, drilling, well completions, production processing, transportation, and more.
Petroleum engineer that works with reservoirs, so people refer to me as a reservoir engineer. If you don't know, a reservoir is an underground area that contains oil and gas in the rock pores. Reservoir engineers help determine how much oil and gas is in a reservoir, how much can be recovered, and how quickly it can be produced. We also determine what types of wells should be drilled, how many are needed, and where they should be located. We work with reservoir models that are built using seismic data, well logs, production history, and other information. These models allow us to perform simulations that help us determine how to manage a reservoir. There are many options involved in reservoir management, so we perform economic evaluations of options to help our company make the best decisions. Finally, we prepare periodic estimates of remaining recoverable reserves. These estimates are relied upon both inside our company and by outside investors, so it's important that we get them right.
My job is to design and oversee the drilling of wells, so I'm called a drilling engineer. Drilling can be extremely complicated. We have to drill holes that are often more than 2 miles deep and have to hit a target with tight accuracy. We have to safely drill through formations that could cause problems, and sometimes these wells are drilled from floating rigs in water that's a mile or more deep. We're told where the well should start, where it should finish, how wide the hole needs to be at the bottom, and what kind of geological conditions we should expect to encounter along the way. The rest is mostly up to us. We'll drill the well in several sections and will periodically line the hole with steel pipe called casing to protect both the well and the environment. We determine how many hole sections and casing strings are needed and how wide each section needs to be to achieve the required hole width and depth at the bottom. We determine what kind of equipment and procedures should be used for each section, including drilling tools, bit types, casing, cement, and drilling fluid that we call mud. A wide variety of supplies and services are needed to drill a well, and we work with the supplier management group to get a rig and all the needed supplies and services to the drilling site at the right time. We can't afford to have a lot of servicemen standing around waiting for their portion of the job to begin, so we have to coordinate activities on a tight schedule. During drilling, we post a company man at the well site and review daily drilling reports to make sure the well is done safely, properly, and at a reasonable cost. Drilling engineers interact with other disciplines to ensure that financial, technical, and safety objectives are clearly discussed and achieved in all phases of the drilling process.
My job is to complete a drilled well to get it ready for production, so I'm called a completion engineer. Completion engineers determine where we should make perforations in the casing to establish contact with the reservoir. We design any stimulation programs that are needed to increase production, such as acidizing or rock fracturing, also called fracking. And by the way, fracking some wells costs more than drilling, so it's very important that we get that right. We determine what kind of tubing and downhole equipment should go into the well to channel production back to the surface. We also configure the Christmas tree, which is a valve assembly on top of the well that controls well flow and well access. If the well needs artificial lift to get fluid to the surface, such as a pump jack, we also select that equipment.
My job is to design and oversee the installation of production processing facilities, and I'm called a facilities engineer. Facilities engineers design the flow line layout to collect and combine production from multiple wells, and we design the process and select the equipment to separate and treat oil, gas, and water. We also design control systems, utilities, storage tanks, meters, test facilities, pipeline connections, water disposal facilities, and potentially much more depending on the needs of the project. The challenges multiply for developments offshore because we need to work with engineering and construction firms to design subsea equipment, platforms, and topsides that can handle all of the working needs.
Last but not least, my job is to monitor ongoing production and field operations. I'm usually called a production engineer or operations engineer. I analyze well performance and production flow and look for ways to improve production and reduce costs. I identify needs for modification and repairs to wells and facilities, and I help make sure that equipment is safe and well maintained. I interact with other engineers to get things done. We don't want our results to be just good. We want them to be excellent and optimal, and that's why they need a coordinator like me.